Welcome to The Explainer. Today, we're talking about something that honestly sounds like it's straight out of science fiction, but it's totally real. It's a material called graphene, and, it has the potential to change pretty much everything. All right, let's just jump right in. I want you to picture something for a second. A material that's so strong it makes steel look weak, and yet it's so thin you can barely even see it. This isn't a riddle, folks. This is the reality of what we're talking about today.
So, what is this stuff? What is this revolutionary material? Well, at its core, it's actually made from something super common, but it's in a form that is anything but ordinary.
Okay, so here's the simplest way to think about it. You know the lead in a pencil? That's just graphite, right? Which is basically just layers and layers of carbon atoms stacked on top of each other. Now imagine you could peel off one single layer, a sheet that is only one atom thick. That is graphene. It's this perfect, beautiful honeycomb pattern of carbon atoms. And the bonds holding them together, they are unbelievably strong and stable. And that simple, elegant structure, well, that's the secret to all of its superpowers.
And yeah, that perfect honeycomb structure makes it, well, ridiculously strong. I mean, we're talking on an atomic level. It is one of the strongest materials humans have ever tested. To give you some perspective, a sheet of graphene as thin as, say, plastic wrap could hold up an entire elephant. I mean, just think about that for a second. It's absolutely mind-boggling.
And the thinness, it's just on a whole other level. Seriously. We are talking about something that is literally 1,000,000 times thinner than a single strand of your hair. This is why you'll hear scientists call it a two-dimensional material. Because, for all intents and purposes, it has length and width, but basically zero height.
So, okay, it's super strong and super thin. What else? Well, on top of all that, it's a super stark conductor. Because of that perfect honeycomb lattice, electrons can just zip across its surface with almost no resistance at all. What does that mean? It means it can move electricity and heat even better than copper. And copper has been our gold standard for decades. This just opens up a whole new universe for electronics.
So you see, the really crucial thing here is the combination. It's not just that it's strong, or that it's thin, or that it's conductive. It's all of those things at the same time. It's stretchable, transparent, flexible, and super lightweight. And that's why this isn't just another material. It's a game changer.
Okay, so we've talked about what it is, but how do these incredible properties actually translate into the real world? Well, let's start small. I mean, really small. Let's look at how graphene is already starting to revolutionize electronics and sensors.
Because it's just one atom thick, its surface area is enormous, relatively speaking. Think about it. Every single atom on that sheet is exposed to the world around it. That makes it hypersensitive. We're talking about sensors that could detect a single molecule of a dangerous gas. And it allows for electronics that are so thin and flexible, you could literally weave them into the fabric of your clothes.
And hey, what about this? We've all been there, right? The dreaded cracked phone screen. Well, since graphene is both see-through and crazy strong, it's basically the perfect material for touchscreens. Imagine a future where dropping your phone isn't a heart-stopping moment. That could be right around the corner. And this is where it gets really exciting, right? The potential is huge. We're not just talking about rigid blocks of glass and metal anymore. We're talking about things that you can bend, fold, even wear. Phones you could roll up like a newspaper. Wearable tech that's just part of your shirt. Computers that are way, way more powerful. Even smart food packaging that literally tells you when your food is starting to go bad.
Okay, so that's the tiny stuff. Now let's scale up. Let's go from microelectronics to the big things that shape the world around us. Because graphene's strength and incredibly lightweight could have a massive impact here, too. And you know what? This isn't some far-off future theory. Graphene is already here, in the real world, right now. Companies are mixing tiny amounts of it into other materials. They call that a composite, and it's making everyday products way better. For example, think about high-end running shoes or tennis rackets that are suddenly way lighter, but also much, much stronger than they used to be. That's graphene at work. And you can apply that same idea pretty much everywhere. Lighter parts for airplanes, that means better fuel efficiency. Stronger materials for cars, that means better safety. You could even use graphene composites to build taller, more stable skyscrapers, or create coatings for ships that make them totally rust-proof. It could also completely change the game for energy storage. I mean, think about the batteries in our phones or electric cars. They're limited by how fast they can charge and how much heat they build up. Well,
Graphene's amazing conductivity and massive surface area basically lets you build a superhighway for energy inside the battery. The result? You could charge things up in minutes instead of hours. And it would do it all while getting rid of heat, making the whole process much, much safer.
So, okay, making our gadgets and our cars better is one thing. But graphene's unique structure also offers some really elegant solutions to some of the biggest, most serious challenges that we face as a species.
Let's start with a really sobering one. Water scarcity. It's a huge growing crisis that affects hundreds of millions of people around the globe. Finding new, more efficient ways to get clean drinking water is, well, it's absolutely critical for our future.
And this is where something called graphene oxide membranes could be a game changer. The best way to think of it is like the ultimate coffee filter, but on a molecular level. You can engineer this material with pores that are so perfectly and precisely sized that they let water molecules slip right through, but they physically block anything bigger, like salt molecules or other impurities. This could make desalination, turning salt water into fresh water, so much more efficient. And the list just goes on and on. You've got food packaging that creates a perfect barrier against oxygen, keeping food fresh for longer. You have sensors that can help farmers use less water and less fertilizer. There are even new ideas for using it to capture carbon emissions right from the source. Graphene is really like a whole new toolkit for building a more sustainable planet.
So with all of this incredible potential, where are we right now? Are we really on the edge of a full-blown graphene revolution?
Well, think about this. Graphene was only isolated for the first time back in 2004. That's not that long ago. Just 6 years after that, the discovery won a Nobel Prize. And today, we're already seeing it pop up in actual products you can buy. That speed, that pace of innovation is almost unheard of in the world of materials science.
But here's the thing. As amazing as all of this sounds, we are really, truly just scratching the surface. We have only just begun to figure out what we can do with this one atom-thick wonder material. And that leaves the most exciting question of all, really. What comes next? What will we build with it? That's a question for the next generation of inventors and builders and dreamers to answer.